Good morning, Accelerated Math 6-7 students. We are still working in Module 4, and we will be starting Lesson 4 today. The name of Lesson 4 is Replacing Letters and Numbers, and it can be found on page 68 of my comp book. Replacing Letters and Numbers is the title. Our goal for today we will learn what a variable is and how to use it to evaluate expressions. I'm pretty sure that this is a review, but we'll go over it just in case it's not. The question that I want you to be thinking about during this lesson is, can a single letter stand for more than one numerical value? And I would like you to explain why or why not. Some important information that you need to know. Pretty much I'm going to tell you right now, this entire lesson of notes that we're going to take is vocabulary. So a lot of the words that you're going to be seeing are going to be the words that you need to be able to understand without having to reread your comp notes. So if we can learn these terms and you can get them in your brain and remembered, that would be good. So for example, the word variable. A variable is a symbol, usually letters, that is a placeholder for a number, okay? A lot of times the most popular variables that are used are like the letter X or the letter R or the letter S or the letter T. A lot of times you're going to see letters, and that's the symbol that represents the unknown amount. So that's called a variable, okay? An expression is a math sentence that has one or all of the numbers replaced with variables. So for example, an expression would be 1/3 times the quantity x plus y plus z. And you will notice that x plus y plus z are all variables, and that 1/3 is the coefficient. And so an expression also needs to be remembered that it does not have an equal sign, so you can't solve it. The only thing that you can do with expressions is you can combine like terms and simplify them, but you cannot solve them. So an expression is a math sentence that has one or all of its numbers replaced with variables. An equation, however, is the use of those same things, but there is an equal sign present. The next word that I need to talk about is evaluate. Evaluate means to solve a given expression or equation or problem. So evaluate is a different or fancy way of saying solve, okay? And I think a lot of you have asked me that before when you've come across different problems that say evaluate. Evaluate means to solve. So to solve a given expression, equation, or problem. So an example of this is x plus 3 equals 5. So your job is to figure out what number plus 3 equals 5. And so you know very easily that that number is 2. So x has to equal 2. 2 plus 3 equals 5. Okay? So that's what evaluate means. Right? The next one, I'm hoping this word is a review. I think it is, just because I've talked about it in class before. But area. Area is the space that is located inside a given shape. To find area, you take the length and multiply it by the width. Multiplying two things makes it two-dimensional and squared. We talked about this a lot on Friday, so hopefully you all remember that. The next word that I need you to know and be aware of is volume. Okay, I had to turn the page, so again, put the title up at the top. The next word is volume, the space inside a three-dimensional shape. To find volume, you take the length, the width, and the height, and you multiply them together. Multiplying three things together makes it three-dimensional and cubed. Okay, so volume is three things multiplied together, length, width, and height. The next thing that I need you to write down and be reminded of is the additive identity property of 0. Any number added to 0 will always result in the number itself. So examples of this: 7 plus 0 equals 7. 1/2 plus 0 equals 1/2. T plus 0 equals T. Okay. The next one that I need you to write down is multiplicative identity property of 1. Any number multiplied by 1 will always result in the number itself. And so 7 times 1 equals 7, a half times 1 equals a half, and t times 1 equals t. So now I want to take a quick minute just to talk about these two, because these are properties that we use to help us. But there's something that you need to notice. When you're adding something and you want the number to come out to be the exact same, the number that you choose to add to it is 0. But when you're multiplying something and you want the answer to come out to the number itself, you have to multiply it by 1. So that's a very, very good tool to remember, that as long as the operation is adding, you have to add 0. If it's multiplying, you have to multiply by 1. And both of these will result in the original number that you are working with will be the same number at the end. So again, any number added to 0 will always result in the number itself. Any number multiplied by 1 will always result in the number itself. Okay, so those two are really important that you get those straight. Okay, the last one that I have for you is the commutative property of addition and multiplication. The key thing to remember about this property is the order that you add or multiply numbers does not matter as long as you are adding or multiplying. The solutions will always be the same. And I came up with a couple of examples to show you this. So 5 plus 2 is the same as 2 plus 5. Why? So what I would like you to do on this one is I would like you to come up with a solution to both of these and see if we are correct. 3 times 9 is equal to 9 times 3. Again, come up with a solution and see if we are correct. 1/2 plus 6/4 is equal to 6/4 plus 1/2. Again, I would like you to find the solution of these two and see if we're correct. Remembering with fractions, you have to have a common denominator before you add. And the last one, 2 times t is the same as t times 2. Again, come up with the solution and see if we are correct. You should notice something once you actually do the operation and figure it out. Okay? So again, these are a lot of vocabulary terms, and we didn't really do any actual replacing letters with numbers, but there's a lot of terminology that when you're in the practice of replacing letters and numbers, that you need to know this terminology to understand what the problems are asking you to do. So that's why I felt like this was a good set of notes for just vocab lesson. So go back to our goal. Today we will learn what a variable is and how to use it to evaluate expressions. When you get into class, you will see the purpose of all of these words, and you will get to do some actual evaluating. The question, can a single letter stand for more than one numerical value? The answer is no. And the reason why it cannot stand for more than one is because we as mathematicians wouldn't know which numerical value to use if it had multiple values. So the answer to that is, can a single letter stand for more than one numerical value? No, because there has to be one numerical value that stands for each letter or each symbol that is used during an expression or equation. That way we can solve for it and figure out what that variable is standing for. All right, my darlings, that's all we have in this lesson. Not a lot of actual math stuff, but some good term building. And I will see you later. Bye.